Now,
Okay, how was your okay? How was the material? How did you find the material? How was the how was the linear algebra?
yeah, let me say, I'm not a mathematical person, so I don't have any, let's say, I don't have solid background in mathematics. So I found it somehow hard, but as the tutor was explaining, so I got some idea about it. So I was trying to do some calculations on the lab, but I did not know how to do that. So
Oh
I
wow.
I think that that is going to be explained today. Sure.
Yeah,
So
no problem.
that was
No
it.
problem. No,
Thank you.
no problem.
Yes,
Yeah,
sir.
we should have the instructor that taught the course should be available today. So feel free to ask him any of your question, anything that I feel like is not clear. Okay. It seems people are taking their time today. What is
Uh,
wrong? Did
uh,
everybody did you all receive the mail?
Yes, I did.
So what may be wrong? Okay, so yeah, anybody who else wants to go next? Everybody else wants to go next. Okay, have we the previous week ED have we all done it? Have we all done it? Hello. Okay, okay. I'm going to say there's something. Okay. But who else is not done? Who else is are we still contemplating about anything? What exactly do we have any issue? Anything we want to talk about? I guess those people are not in the mood to chat today. Okay, so my week was great. Thanks for asking. Um yeah, it was full of a lot of stuff and um yeah. So okay, it was really interesting to work the exploration data analysis, right? Would you care to share your findings? What
yes,
did you find out?
yes, sir. Yes, sir.
What were your findings? What would you like to share with us?
Ah, what I do? Like, actually, I worked on this video game status. I think video game stuff, VGS. So it was a data set that I downloaded from Cargo. So I looked into the most sellable game in the EU, European, then I think, yeah, European, global, yeah, global market and stuff like that. So I have all those column there. I was just trying my hand differently on everything that I can explore. So it's not actually anything professional there. It's just like I was trying what I've learned. And I found it interesting. So structuring bar charts and viewing as in seeing my bar charts with different color. It's really interesting. Like wow, sure I can do this. So it's actually fine. Thank you so much.
Oh, um, oh, that's nice. That's nice. The thing, like when you were plotting it's not just about you. Apart from you plotting the bar charts, and the bar chart, the histogram, and everything. What, like, in your bar chart now? What did you find out? Like, the relationship between all these gaming stuff in Europe. What can you say offhand regarding the interrelationship?
Yeah, actually, I was okay. There are several platforms. As in, okay, let's say I have some publishers like Nintendo and other stuff. So I was trying to plot which publishers sold a lot of game on platform on online. So I found out Nintendo people tend to love Nintendo games than other games. Then in USA, like in North America, PS2 actually is the most acquired game then. So I think it was then games down people downloaded more game in 2000 and let's say in 2002 than 2000 2020. So I found out, so people are not ready to people are not having that kind of chance to download more game in 2020 due to the COVID-19 of a thing. I don't know. So I found that games were more acquired in 2022 than 2020. So another thing I found that people downloaded which this action game better than other strategic game and stuff. So those are I shall explore anyhow, sha. So it's just like
That's
we play
nice.
now.
That's very nice. That's very nice. That's very nice. But you see that kind of, when you had a game in 20, a game in 2020, I feel like they were not like download, like people, there was not much download. You could like further investigate that what could have caused that. So you already did that in that. So it's majorly about, exploring. You dive into the data, you do different plots, and you see what exactly is going on. So, this can help make business decision. So that people download more games from, was it Nintendo?
Yeah, Nintendo
Eh,
platform,
eh,
Nintendo publish.
exactly. So if you want to publish your game now, definitely using that data, you know that okay, if I go with Nintendo, more people are likely to like download my. If I'm partnering with Nintendo, do you get? Oh, it's just about exactly data and storytelling, just about understanding what exactly is there. And then, so if you are in an organization now, so you won't just be showing them, but you'll be showing them, okay, so if we are going to do this, if you are going to do that, we should be partner. So this is the best decision, not just because I think so, yes, but because the data is actually saying that. So that's basically what it is about, exploratory data analysis and stuff. Yeah, stay telling stories with number. Anybody else wants to share their findings? Just a brief summary of what you found out when in your data sets when you were while you were exploring. Anybody else? Hmm? It seems, are we discouraged? I don't know why I don't know why people are not on the call today. Yeah, are we discouraged? Why do you think, does anybody know why people are not on the call today? I think the last time we had the low turners was because we didn't send the email on time. So please, does anybody know what might be wrong?
I think maybe because there is no assessments this week.
Oh, okay. Because there's no assessment this week, no problem. All right. So I think we'll probably look into. Okay, we'll look into that. Okay. All right. Okay, let me share
Good morning.
my who's speaking? Is anybody speaking? All right. Okay. Let me share. Okay. Can we all see my screen?
Yes, we can.
Okay.
Yes, we can.
All right. So this week we went into so as this okay so yeah, welcome everyone to week 4 uh community session. Yeah, so we are glad to have everybody on board. Welcome, welcome, welcome. So yeah, this week we dived into yeah, mathematics for ML and linear algebra. Okay. We did dive in. Yeah, this was the video, and I loved this. I love this illustration by the instructor. Okay, but before we proceed, I want to involve in a short in a poll. Okay. I want to know how many of us like watched the video. How many of us watched the video? So I just want to know how many of us watched the video. I've sent a poll. I've launched a poll. I want to know how many of us watched the video. Okay. The person that did not watch the video, do you want to share why you did not watch the video? Do you want to share why?
Yeah, good morning.
Yeah, good man.
Yeah, it was because I wasn't around for the video, so I will check it this weekend today after the call.
Okay, all right. No problem. Okay. Then, okay, out of those of us that okay, let me end this first of all. Out of us that watched the video, I want to know how many of us like understood the concept discussed, the concept of linear algebra. Oh, sorry. Oh, sorry. I relaunched it. So I want to know how many of us understood the concept of linear algebra. I've launched the poll. Okay. Okay. Well, it is nice that we already like, but those that don't understand it, I hope we've all, well, those that's kind of, and those that I don't, I hope we've all like watched the video. Have we watched it?
Yes, seen it.
Yeah. Okay, if you've seen it, so at least, so prepare your questions. So I'll get your questions ready. The instructor, I'll be inviting the instructor off first, but just want to understand where we are all at. Okay. Okay. So let me. So how many of us interacted with the notebook, with the lab notebook? How many of us interacted with it? Oh, okay. Cool, cool, cool. Okay. Okay. All right. 3 and 7. Okay. All right. I think that's okay. I think that. So since if we interacted with the instructor will be coming up soon. So yeah, thanks for engaging the pool. At least we know that you guys did uh did the did your best. Okay, so is Mr. Kenneth on the call yet? Is Mr. Kenneth on the call? Right? So okay, basically, what's in here? Please let me know when our instructor. I think our instructor hasn't joined. Let me know when our instructor joins. So I will be able to. So did we all so linear algebra is just a means of utilizing it's just a means to introduce us to what exactly went on is going on behind the scene in is what is going on behind the scene in a machine learning algorithm, because we'll be doing a lot of algorithms, we'll be using models, we'll be doing data manipulation, we'll be doing a lot of normalization and stuff. So the basic idea of linear algebra is for us to actually like understand what this when we are actually calling different functions. We are calling different functions. At least we have a bit of knowledge of what exactly is going on. Do we get that? So that's basically what linear algebra is trying to tell us. So don't worry, it is not too tough. It might look tough at the beginning, but it's not too tough. It is still linear algebra. It's still like the basics. Okay. So Mr. Kenny, are you on the call?
Hi everyone, can you all hear
Okay.
me?
Yes. Welcome, sir. So our instructor is on the call. The same man that taught discourse few years ago. So yeah,
Oh,
you have the floor, sir. You have the floor, sir. You can
oh,
share. Let me stop
oh,
sharing my screen.
Kenichi.
Yes, sir. Okay, you can introduce yourself, sir, and proceed with the call, sir.
No problem. This it's just Kenichi. So
Okay, sir.
yeah, uh, just give me 1 sec, please. Okay. Hi everyone, can you all hear me? Sorry, it's a bit early at my end. Um, so yes, I took the course. I think I don't know how many years ago. All right. And for this cohort, my expectation was that that you all have probably gone through the content of the video, and then we could discuss, and then I could probably answer any questions you all might have, right? Regarding linear algebra, more or less like a discussion kind of class. So what the first question is, have you all been able to go through the videos or the slides? I usually like when people speak.
Yeah, thank you, sir. I've gone through the video. Okay, sir.
So let's make it interactive. So if I remember correctly, usually at the end of classes that I give, I usually put an assignment there. So let's start with the assignment. Did anybody attempt the assignment?
No, really, sir. Because according to the organizers, they said the week that we used like the past week is assessment free, you know. So there is no sign of assessment for that.
Well, I think it was a fun thing, right? If I remember correctly, you're supposed to play around with images. So I don't think it's something that you probably need to submit for the cohort, right? But it's something that it's something that you could just try around, try to just test your knowledge. So one thing I would like you all to understand is that um, the duty to learn, right? Within the cohort, within the structure of the cohort, right, is your responsibility. But you also have the responsibility to learn outside the structure of the cohort. And that's what even makes you better, right? If you rely only on what the cohort gives you, then you're limited, right? So yes, we'll do our best to make sure that you're well equipped, but it makes more sense if you become a better engineer if you do things outside that scope, right? So I'm trying to pull up the slides. One sec, please.
Hello, please, I can't hear Mr. Kenichi.
Also here, I think maybe his network is down.
He
Maybe
said
he
he
needs
said
to.
he said 1 second.
So just give him a second. He will join back.
We are not hearing anything, that's why.
Okay, everyone, can you hear me?
Yeah, so Kene is having some issues with his network.
Yes,
Just
can
give
hear
him
you,
a
can hear you.
second. He would join back. He would let you know when
Okay.
he's available. Yeah, I think Yomife will take over now. Once Kene is back, we'll let you know.
Okay. All right. So excuse the network. Okay, so okay, let me use this issue, let me use this privilege to just like go through. For question 1 and 2, okay, let me just while we are waiting for Mr. Ken, for question 1 and 2, how many of us still have issues with it? Can you just signify if we still have issues with question 1 and 2, like of the SQL assessment. Can you just let me know. Like nobody okay, Firdaus, can you just
I, I,
unmute?
actually, the answers are already in the notebook that was shared.
It's yeah, kind of, yeah. Thing is, okay, Firdaus, can you speak? Can you unmute yourself? I'm not hearing. Is it just me, or I'm not hearing you clearly? So is everybody hearing Firdaus?
Hello?
Speak. Okay, I can hear you now.
You can hear me now. Okay, yes, I just wanted to clarify if by like having a problem with questions 1 and 2, do you mean that the options I'm getting or the values I'm getting are not in the options or like something else?
Yeah, yes, exactly.
Oh yes, I don't have a problem with the query part, it's just the values I'm getting are not in the option.
Yeah. Okay. So after we reviewed the stuff, we feel like okay, um, I'm coming. Sorry, give me a few minutes. So the thing is, after we review, so I feel like okay, probably like the I think easier is better. So Frida, so what were the answers you were getting?
I'm coming. Let me just go to my notebook really quickly.
Yeah, this is so I think that was the issue. I think some people were getting okay, I think people were getting different kind of answers. So okay, probably people were getting different answers. So I was just like okay. And after we reviewed it, I don't know if I should say what the answer eventually, what we feel like the answer is. I feel like probably the answer is a bit different because after we tried it, after trying a different approach, after trying a different approach, we found out that what's it called? The different approach gave us a different answer. Mm. So those are just on. So this was just to like those of us, those that were getting different answers. So I just want to know what were the answers. What were the answers we were getting before I go into.
Hello, Yamife, can I go?
Yes, you can.
Okay. Good morning, everyone, and thank you for your support during the week. Regarding the question 1 and 2 for assessment 3, okay, for me the options were very high, and that led me to maybe okay, let's go very raw. When I mean raw, I mean let us open the data itself and then do a manual counting of the manual value that we have. So, and if you look at the period for January, it was those values were very small. So I think at the end of the day, they should be less than maybe 15 or 18 thereabouts for manual and the second one. So If we go the manual way, we will get that something very small, which the options on the form are in their 500s and above. So which makes it very large. So that's why I was suggesting that if anyone was able to also open the data itself and then check manually instead of writing queries, what values were you able to count for the period of January 15 to 31st, I think 18 to 31st. So that was
Hello?
my own. So I don't know if that approach works for everybody or what the conclusion will be.
Yeah.
Hello?
Thank you.
Yeah. Hello.
Yeah, so I just opened my notebook and I think what I got for the clerical, where occupation was clerical, and then streamlined my search to January 2015. The total orders was 28, and for the manual, it was 13. That's for January 2015. I don't know if any other person had a similar value.
I think Chisom, you are correct as well. That's around what I got.
Okay, you know what? Let us deal with this later. I think Mr. Kenichi is back. So let us so would when is it will just like go over the stuff with us in a few minutes, and they will so when he's done we'll we'll treat this before we end the course today. So welcome back, Mr. Kenichi. Thanks for joining.
No problem, thanks. Can you give me permission to share?
Okay, so I have to make you co-host, right?
Yeah, I think so. Or you just give permission directly.
Try sharing your screen. That's it. That's for permission.
It's my screen.
Yes, you can see it.
So, okay, so I'll go over this notebook that I created. I think this is probably a year or two ago. And let's walk through it, right? Some of the things that are in there. I'll I'll explain. I'll explain them. Um, but hopefully, I would expect that we have questions, right? Um, it might sound a bit more like engineering, programming, but I'll try as much as possible to give you the concepts there, and I'll still encourage you guys to all check the videos. So typically, I mean, when doing linear algebra, all right, the, there are some very key libraries in Python that you'll want to utilize, right? I think the first and most important one is NumPy. So NumPy is literally the foundation of whatever linear algebra thing you're going to do in Python. All right. Not does it only help you do those very complex linear algebra operations, right? And very simple ones. It helps you to also do the very complex ones. But as you go deeper in machine learning, deep learning, right, you'll get exposed to some other very, very powerful tools. I know there's one the NVIDIA built. I don't know how far they've gone with improving that library, but it's all based off NumPy. But then again, right, beyond just the linear algebra operations, right, there's a piece of plotting. So you also want to be able to plot um, um, whatever your operations you're doing, at least have some sort of visualization to know that at least whatever picture you have in your mind of that linear algebra operation is as expected. Some of the libraries you would use is, I mean, the first one that everyone would always reference is Matplotlib. And some extras are just Plotly, right? And then there are other sub libraries under Plotly. These ones are just Python widgets to just enable us view things in a specific way. So I'll run this. So here I've written some like Python plot functions. I wouldn't see you put so much focus on it. But they think of it as helper functions for now, right? The core things that you want to learn is the linear algebra, right? For now, again, I don't know the level of expertise everyone has in plotting. Well, for now, the basic, like passing an array, two arrays, right? And I plot those two arrays against each other on an X and Y axis and see what they look like or what the curves look like. I think that suffices, right? So for now, these are just helper functions that I've put in place to help you visualize some of I would call it somewhat complex things, right? Um, so there's this one, right? So this one is just basically going to help you plot the vectors on an X and Y axis. Every other thing you see here is visual, it's prettification or whatever we call it, right? And this one is just to give you that plot in a 3D form, right? Um, this is the same, this does the same thing, right? The only difference is that one was with Matplotlib. This one is just with Plotly, right? So the majority of the things that you'd see Matplotlib do is similar to what you'd see Plotly do. But Plotly is more, I, I'm tempted to use the word advanced, but it's not necessarily advanced. I think it looks more beautiful, right? Um, and similar to the previous ones, like there's this one, the 3D version of Plotly. Okay, so now let's create a vector. Let's go to creating vector. Can anyone explain to me, right, what they understand by vectors, right? Anyone?
Can you hear me?
Oh,
Yeah, can you hear me?
yeah.
Okay, a vector is a single array or a single column matrix.
Okay. So that's vector from a Python programming perspective, which is correct. So I give it to you. Can another person tell me? And that's correct too, right? So but can any other person give me another, maybe someone should give me the definition of a vector from a maybe physics, mathematics kind of perspective.
Okay, if nobody is, probably I can just say, okay, because a vector is a an object that has both magnitude and at the same time direction.
Okay, nice. So I forgot to mention, right, that usually I like to give gifts at the what's the word when I teach. And it's interesting because at the beginning of this cohort, like I said at the beginning, right, the expectation is that everyone goes through the content and we come and take a look at the content and discuss it. So it's a bit more encouraging, but it seems like only few people took a look at it. So for the two individuals who responded, right, I'm not trying to piss anyone off, just disclaimer, right? I'll give the equivalent of $5 each. So I have, how many more $5 do I have? Two, two $5 left. All right. Maybe it will increase, but let's see how the participation goes, right? So yep. It's I sorry. Did someone
Yeah,
say
sorry. Sorry. Good morning.
good?
Yes. I put something in the chat.
Oh, I didn't know. I like it when people speak. You can feel free to unmute.
Okay. Okay. So I said vectors are used to represent.
Points. Yeah, points in a space, right? So I'll give you also that's 15. So I have one more. But the question for Vector is gone. Right. So
Oh my
maybe
God.
I'll give it to two. So that's 15 bucks. But Yemife, please help me with the names and accounts so that I fulfill my promise. So yeah, so you're all correct, right? So vectors can be one-dimensional, and when we say one-dimensional, it could be that's pretty much your most times scalar. Um, um, it could be two-dimensional. That's when you're having your XY axis, right? So you could get, meaning you're defining something in an X and Y direction, and it could be three-dimensional, right? X, Y, Z. It could be 10-dimensional. And the interesting thing is that as you go deeper in machine learning, you're going to, especially deep learning, you're going to be seeing crazy dimensions, right? And the interesting thing is, and I'm certain I've probably said it before, right, is that if you don't have a good understanding of how things work in the one-dimensional, in the two-dimensional space, and in the three-dimensional space, it's going to be really hard for you to extend that knowledge to multi-dimensional spaces, right? So, oh God, I've given the answer here. Let me cancel this thing. Clear output. Yeah, but I was running it to be sure that they all work as expected because this life is changed. So there is something
Sorry,
called the receiver. Yeah.
sir, can I ask a question, please?
Yes, please.
The vector here, is it the same thing as the vector in physics, where we talk about a quantity with direction and magnitude?
Well, you can look at, so now the thing is that this is where um the the fields in where you're describing, or the fields where you're using these gadgets, right, really matters. Um, in machine learning, you can look at it from the perspective of from the mathematics perspective, right? Just mathematically, um, and and just get what is needed, right? This times this gives you this plus this gives you this, and you're done, right? But there are some other machine learning engineers who I have experienced that would go deep into the way things are in physics and come up with some sort of intuition, and those intuitions are actually right. But more often than not, right, it's looked at from a mathematics perspective, right? The programming perspective of vectors just only helps us compute these things programmatically, all right? But most often than not, you see people approach it from a mathematics perspective, right? I don't know if I answered the question.
Yeah, I'm okay.
Okay.
You said
So, yeah. So, um, in creating vectors, right? In Python, pretty much like I said before, right? What you need is NumPy, right? As you see in the above, we had imported NumPy as NP, right? Where am I going to? And so this is a sample of something called a row vector, right? So it's this is a three-dimensional vector, right? But it's a 1 by n kind of vector. So it has one row and it can have n number of columns. So you could think about it as a special kind of vector, really. But there's also a column vector. We'll be exploring these two kinds of vectors. So when we say row vector, just like the name implies, right? It means that it's row vector because it has a single row, right? So one row, and it can have multiple number of column, right? So in this case, my question to you all is, so if I say it's 1 by n, so what is the n in this case?
1/3.
1/3.
By TV.
Yeah.
1/3.
True. Correct. And if I say, when we when we talk about the case of the column vector, so what's the expectation? Is it also a 1/3?
No,
I
it's
think
a
it's a
3
3
by
by
3
1.
by 1. 3 by 1.
3 by 1.
it's 3 by 1.
Sorry. Correct. So you guys are correct. Thank God I didn't put any money down because that's how the number. So when you run it, right, this is exactly what it looks like, just like the name implies. It is a row vector, meaning that this is one row, and a column vector, meaning it has just one column. And this is what it will look like typically for a column vector. I personally was a bit confused initially. Like, why do we have two boxes, right? But really and truly, right, the two boxes are it's just a thing of representation, right? Okay. So there's also there are operations that you can carry out with vectors, right? Similar to operations that you can carry out with scalar values. You can do your vector additions, vector subtractions, um, um, multiplication, that's cross products, and all the rest of it. Okay, let's see if we can ask another question. Again, it's supposed to be interactive. So if we are going to do a vector addition here, who can tell us what the value would be?
Can I talk?
Yeah, but no price.
Okay, so I think it should be 2, 4, 3. 2, 4, 6.
2, 4, 2, 4, 6. Okay. So if we do vector subtraction, what would it be? Is it 2, 4, 6?
Yes, no.
Oh, yeah.
7.
Yeah, you're right. I did I mix up something here? Why is everything scattering like this? 2, 4, 6. Okay. Yeah. 2, 4, 6. You're right. Okay. So if we did vector subtraction, what would it be?
It should be like the subtraction. So to be, I think it's 0, 0, 0. So I think they call it 0 vector.
Yeah. Okay. Nice. So now we plot these two vectors, right? So ideally, when you plot a vector on a graph, right, you should see those vectors represented on the graph. So this is a row vector, right? No, this is not actually not. Is this a row vector? Let's say somebody listened the last time.
Yes, it
Or
is. It's 1 by n.
Is this a column vector?
No, it's not.
It's what? A row
Yeah,
vector.
they are both row.
So now we plotted the
Yeah,
two
both
here, right? Vector A is supposed to be in color red, vector B is supposed to be in color blue. Where's vector 1 rather?
It's underneath.
Nice.
Superimpose.
Correct. Nice. I have professors here. Okay, good. I think I jumped to the idea. Is that?
Sorry,
Can I ask
please,
a
can you?
question?
Yes, sir.
Okay.
Does it mean that a vector can be the same vector can be a column vector, the same can be a row vector, depending
No.
on what you're doing? That way.
No. These are both
Since
row vectors.
Please, can you explain the plotting? I understand that we had 0, but I just don't know, like when we had 1, 2, like why I stopped at 2. Like, can you just try to like plot it? Like, so I can understand why the graph is like this.
Why the graph is like this. So this is a 2D plot, right? I agree.
Yes, I agree.
Good. And because it's a 2D plot, the expectation is that, I mean, if you take it as a 2D plot first, right? Close your eyes to this 3. Close your eyes to 3. Cover this 3 with your 2 hands. On your x-axis, why is this writing y here and x? Okay, either ways. On your x-axis, you have 1, right?
Yes. Yes.
This is 1. On your y-axis, you have 2. And this is 2. Right? On your z-axis, which you cannot see because this is not a 3D plot, you have 3. So this is meaning that this plot is at an angle on a paper. So if you think of this 2D as a
It's kind
paper,
of bending.
you don't call it, but it's pointing at an angle somewhere, right?
Okay.
On a three-dimensional plane.
Okay. So my question is, sorry, I'm very sorry. My question
Yep.
is, how did you guess 1 and 2? I thought we were working with the numbers inside the brackets, the box brackets.
Which numbers? Which box bracket?
So I'm seeing vector 1 and vector 2. So I think that's what we're plotting. So vector 1, we have a bracket, so we have 1, 2, 3. And vector 2, we have a bracket where we have 1, 2, 3. It's inside the graph. By the side of the red and the
Okay, I'm a
blue.
bit. This place.
Yes.
Okay.
So I was wondering, I thought we were putting the numbers inside the
Oh no,
brackets.
it's the number inside the no. So vector one is just a name. You can call
Okay.
it vector A, vector B. You get it's just vector one is the first vector, which is an array or a list of 1,
Okay,
comma
yes, I understand what you're
3.
saying now. Thank you.
All right. So sorry, this might have been confusing. I didn't even know. Probably this needs to be updated.
I just realized now that the numbers inside the brackets is supposed to be X, Y, Z. So I was thinking
Yeah.
you're putting vector one against vector two instead of I didn't know you were putting just the XYZ inside vector one.
Yeah, it's XYZ. And remember we said this is three-dimensional, so that's
Yes.
why it's XYZ.
Okay.
Right. Okay, cool. I don't know if there are any other questions. Any more questions? Okay.
Yeah,
So,
yes, sorry, one
sir?
more question. I wanted to know if it would be possible to plot the same thing on a 3D plane or something where we can probably go and visualize how it looks in real life.
Yeah, so let's try it out. Maybe we can try it here. Well, I think this should do it. Let me see. Okay, fingers crossed, everybody. Is this recorded? Yemife?
Yes, it is. Yes, it is being recorded.
Oh my God. Is this going to go public?
Yes.
I used to play a lot too.
It's been like strength actually.
Okay, so do we see it? Do we see it now? Do you see what we were saying? Or does it make sense?
Yes, yes.
Right. So you see, if, like I said, if this was a plane or a paper, right? This was a paper, your um your stuff, like your vector is going to be at an angle towards the what's the word? The y the z axis, right? Maybe we can even do something more interesting here with, I think with this one. Uh, oh, okay. So, I mean, that's something's probably wrong there. But I think we get the gist, right? Okay. Okay, so vector additions, um, I think there was someone who had done this before. So it's basically the same thing. You do your addition, you do your subtraction, and we can go ahead to try plotting graphs of these different graphs. So we have the vector one. This is a vector one. This is a new vector one that we defined actually, right? And vector one, vector two, and when you do a vector one plus vector two, you have 2, 2, 7. Vector one minus vector two, we have 2, 0, -1, right? And that gives us, um, um, if you're going to plot this, that will give you this, right? So we already went over this, and just like I said before, this is a 2D plane, and if it's a 2D plane, it really doesn't give us an idea of what it looks like on the 3D. This is 3D. You can't really use a 2D plot to describe what is in 3D. it makes more sense to use a 3D to describe what is in 3D, right? So let's even do something interesting, right, which I just thought about. So now I'm going to change vector 2, right, to be 2, right? So it's going to be 2, 1, 3. And vector 1 is 2, 1, 3. Vector 2 will be 2, 1, 4, right? And I'm going to ask a question. It's two questions in one, and I want one person to answer both questions correctly. How much have I given so far now? 15. Maybe I'll divide that one to 2.5, 2.5, so that I'll have enough to share around. Okay, so okay, let's make it 5. But it's a different person. No, let's make it 3 because it's a simple question. So it's going to be 3 marks. When I plot vector 1 and vector 2, right, what should happen? What will happen on a 2D plot?
On a 2D plot,
Yep.
vector 1 will be layered over vector 2, superimposed over vector 2.
What will happen on a 3D plot?
On a 3D plot, vector 2 would be slightly more inverted than vector 1 on a 3D plot because the Z-plane is visible on 3D plot.
Is it inverted? That is the word.
Or vector 2 have a longer depth.
So again, magnitude means I need to be longer. One will be longer. May have the same direction, may have different direction. But yeah, I think you get the point. Right. So my that I said 2 questions in one. I think it's 3. The third one is, did you answer a question before and you now want to eat all the money?
No, I didn't answer a question before.
Okay, so let's try it out. Someone's hand was up. So you're right to say it will be superimposed. They'll be on top of each other. Let me now ask a very tricky question. Where is this green guy coming from?
Green guy?
Yeah.
Green guy is vector.
That's vector 3.
Nice. So why is vector 3 on the same line as vector 2?
Because they are into the same direction, and vector 2 in
Yes, the
that
same
position.
direction.
Vector 3 is like a resultant as well.
Yeah, you guys are good.
Nice.
And when we plot this guy here, we see the difference between all of them, right? So you see that in vector, they're actually not really in the same direction, like you said, but you see the lines in the 2D that
3D exposes.
exactly. All right. So that makes sense. Someone else raised his hand. I don't know. Someone raised his hands.
I think the person was trying to also attempt the question that you asked.
Oh, okay. No problem. I mean, there'll be more questions, obviously. So there are some to-dos, right? I don't know what I meant by.
Hello, Kenichi. So did I get it?
Yes, you did. It's but it's $3, not $5.
Yeah, hooray to me.
Okay. So there is I think the expectation here is for you to try out multiple other subtraction operations, right? And then there is also scaling. So here is what happens if we scale one of the vectors by a factor of 2. What do you notice, right? I think we touched on it a bit, right? I mean, we actually did touch on it really, and then we saw the lies in the 3D plot. But I would encourage you all to try out a lot of operations, right? I know I'm asking here what is 2 called. I'm not going to ask it as a question because I know I mentioned the word some in one of the conversations. So what if you're going to be scaling your vector by 2? What is 2, right? That 2 that you're using to scale those vectors, and what is it really, right? And the next piece is cross product, right?
Sorry, I want to ask a question. I've been raising my hand.
Yep, sure.
Okay, about the plotting. I noticed that all the plot is in the, if we are to look at the scale, is in from 0 to 2. Is it because it's in 2D?
From 0 to 2. No, what do you mean from 0 to 2?
Like on the graph. The
Okay, you mean this one?
yes, all the plotting falls from 0 to 2. So I want to know, is it because it's a 2D?
Yes, so because this is just XY, right? What you're going to see as, or what is going to be represented on this plot is just the values, the XY values, all right? And the XY values here is, something is different here. It is 2. The XY value is not correct. The XY values is 2, 1, 2, 1, 4, 2. So the highest you have is 2, right? And that's why you're having, and that's for vector 3, and that's why you see vector 3 spans to 2 on the x-axis. I don't know if that makes sense. If peradventure you have, say, vector 1 instead of a 1 there, you have a 5, right? You have a 5. If you run the code, you'd see that vector 1 goes up to a 5, which is here, right? And then when you do the computation of vector addition, you have a 6, 4, 6, 7, and that's why you see this goes to 7. And like I said, when you add the third row, which is your z-axis, which makes it 3D, if you're going to be visualizing, so this is 3D actually. If you're going to be visualizing on a 3D plot, which is going to give you like the true representation, you have this here. So you're not just relying on X and Y. You're also taking a look at what's happening on your Z. I really wish Plotly, the plot with Plotly, let me try it. Maybe it would make it look better in this matrix. I'm not sure. So a lot of these libraries get updated, and that's probably why this isn't working anymore. But I'm pretty sure it worked before. But I could take a look at it and hint you, give you guys a heads up. Right.
Thank you, understood.
Okay. Okay. So we want to do cross product, right? So cross product is it's one of the the gadgets, right, in linear algebra. I probably put the mathematical equation, right, in what's the word? In the slides. But basically, it's so as against your normal multiplication, as against doing your normal multiplication as you would, right, um when you're dealing with scalars, right, there is a way to do it in matrix, in linear algebra, particularly um for um I'll use the word objects of the same dimension, right? And the question first, okay. So here we are trying to do a cross product of a vector 1 and a vector 2, right? The formula is something like, I mean, I would encourage you guys to go check it out, verify it, right? But it's something like if you have a vector, say, let me put something here, a vector let's say A1, um, okay, this here is nice one. A1, A2, A3. And then you have a vector B1, B2, B3. The cross product is going to be, let's distribute. The cross product is going to be, wonderful. This thing has saved me a disgraceful moment. Though. All right, so the cross product, this is literally the formula. So let me check if this is correct. One sec. Right, so this is correct. So this is what the cross product is going to be. All right. So it's going to be your A2, right, times your B3 minus your A3.
Sorry.
Sorry, okay.
I think this V1 times V2, I don't think you can represent it like that. I think it's either you say, I don't think you're supposed to use this normal multiplication here. I feel like something is wrong with this code. But something is wrong.
Where exactly?
Well, let's run it and see. We'll use AI to debug.
Okay, let's try. Let's try. I'm sorry. Do we try it manually? Or do you
Yes,
want
let's
to
try it.
Okay, let's try it manually. So this is the formula. What's the person who spoke?
Me.
Sorry, I didn't get it. So I don't see the name.
Okay,
Is it prep?
Chaluka.
Gianluca. Okay. So you I don't know if you have a calculator. Quickly try it, right? Try this and let's see.
Okay.
So we'll wait for Gianluca.
You want to put me in a tight position?
No.
It's correct.
If you get it,
Oh yeah, no problem. No problem.
Hello?
Yep.
Yeah, if you go by what you wrote, like that formula is correct.
Okay. Okay, somebody has got it. Okay. $1. $1 for you. If it's correct, though, if two people say it's correct. Gianluca.
Please go on. I'm calculating, please.
Okay, it's fine.
I think
So
it's
that,
correct. It's
yeah,
1 minus 8 and 2.
yeah, Nice. Okay, so yeah, that's it. That's literally how you do your cross product, right? And why is the plot not looking nice here? Can you imagine? This is the plot that I wanted to, but it's still not. So usually, exactly. So this is what I wanted to show you guys, that you can now turn it around and then you see what it looks like when you turn it around. This is what I wanted you guys to see, but I mean, we're still seeing it here, so it's fine. So here we just plotted the three arrays, right? So your V1, V2, and the result of your cross product, right? Which is your V3, and we can see the plots here. Here it looks nicer. And remember I told you guys that the what's the word? Matplotlib gives you better visualization most times. Plotly gives you nicer visualizations. Maybe Matplotlib has upgraded. I haven't really used it in a while. But you can see here that I can put something here and it tells me, oh, this is X0, Y0, Z0. I can put it here. It's telling me that this is X is what 2, Y is 1, Z is 3, right? And if you come here, it's 2, 1, 3. Here it's telling me it says 1, Y is -8, Z is 2, right? So you see Z is pointing to 2. And you see that it's a bit hard for you to kind of see what is in a 3D. I mean, in terms of what, let me expand it. In terms of, is it a 3, is it a 2, especially in the Z axis. Now imagine what you would want to see. Imagine visualizing something in 4D, 5D, 10D, 100D, 1000D, 10,000D. How do you want to make sense of what is in those dimensions? It's hard, right? But because it might be a bit difficult for you to visualize things in those dimensions, it makes sense that you have good understanding of the computations in these smaller dimensions so you don't make mistakes when you start dealing with things in that dimension, right? Okay. And then we go to matrices. So who wants to tell me what matrices are? So I don't need to raise your hand. Just speak first because
Yeah,
now some
good morning. Matrices is the representation of a row and column in the brackets. This might be in any dimension, maybe 2 by 3 dimension or 3 by 3 dimension.
Okay. So I didn't put any, thank God I didn't put any there. Right.
Hello.
So but it's good. Let me
Yeah,
first
thank
put
you.
how much have I blown like this now? Let me feel how much have I blown like this? Okay.
You think
So
you've
yeah,
done like,
I've done like what?
I think you've done $3, $4, $5, $1, $3, and I think that's all.
Okay. I
Anybody
think
else?
$2. No, it's well,
So I think you did $1.
Yes,
okay.
matrix is a rectangular
Am
array
I
of
then
numbers.
am I among the
I'm answering my own question.
Don't worry, we are
am,
going there. We are getting there.
am I there?
Yeah, you're there. But this one, there was no price.
No
I've
problem. Let me
already
still answer my
okay,
let me
okay,
still
I've
answer
said it.
my own.
So what is my price? So I can tell you if I to
You said?
I said I'm there, so I don't know my price.
No, I didn't hear you, sorry.
But you said I am there, so I don't know my price.
Your price,
Mm.
not for this one. You're going to get there.
Okay,
Um,
thank you.
so similar to the row vectors, column vectors, right? There is there is you also have similar operations, right, in matrices. So we have the addition, we have subtraction. But how, if you're going to, I think I'll start from here. I think my brain is moving too fast. If you're going to represent a matrix, right, in NumPy, this is a way to represent a matrix. So for this matrix, right, someone just tell me what is the dimension of this matrix. I think Said had already been talking about. Said, please just
This is
This is 3 by
three
3.
dimensional.
Two-dimensional.
This is how
3
many
by
dimensions?
Three by
Two-dimensional.
three.
2-dimensional.
It's
Yeah.
2-dimensional 3 by 3 matrix.
I think that's right.
So it's a 2-dimensional 3 by
Said it
3
was
matrix.
two-dimensional.
Okay. It's a 3 by 3 matrix, right? And if we plot this
3
matrix,
rows and 3 columns.
3 rows,
Wala.
right? So can someone and someone mentioned it, 2-dimensional, 3-dimension, 3 by 3 matrix plot. If you plot it on a 2D, it's a plane, right? Meaning that it's literally actually 2-dimensional. So the person who said it's 2-dimensional is correct. So it's a plane, right? Let's see, how do I explain this now? So basically, it's flat, right? Really and truly, that's what it's saying. It's flat. It's a flat matrix. Matrices are usually flat. So yes, you can have what's the word? Your X, Y, Z when you're dealing with what's the word? When you're dealing with so let's say we take this out, right? Right.
How would you put him?
Okay, I think I need to use a different plot here, not this one. Just one sec, please. This one. Mm, mm, mm. Oh, okay. I think I've made a mistake, so I'm sorry. So I'm just going to get this. So, yeah. Mhm. So when you plot, when we plotted this, guys, right? So this is a 2 by 3, right? And when you look at it, it looks like, I mean, it's just 2 arrows, right? However, when you put in the third dimension, right? Or when you make it a 3 by 3, right? And you put that third layer, right? It literally makes so it's literally some sort of transformation, right? In 3D. And depending on how it's plotted, it's going to look like a plane. So that third dimension kind of gives you like a plane over all points, right, that you're plotting against. So when you're plotting a matrix, right, and then you put in that third dimension, I think very simply is, which is this, right, as against expecting to see two, monitor. As against expecting, do you still see my screen? Sorry.
Yes, sir.
Yes.
Yep. As expecting, as against expecting to see two arrows, right? What you literally see is a 3D representation that kind of represents all this of all the spaces, right? So you think of it more as like a space or a plane, right? In that space. So this is literally a space, and then this is the plane on that space. So it's creating a plane again. If you hover over this, right, you can literally see what. Sorry. I think this makes more sense like this. If you hover over it, you'd see what each point represents, right, over the plane. So let's go through it one after the other. I know it might be a bit. So your, I think this should give us a point. Right? I'm trying to figure out where the points are. Try it this way. One sec. No. It is nicer this way. Okay. So if this was our x, this was our y. Let's try to trace this particular row here, right? This is your x, y, z, right? So if this is x1, right? So 1 is somewhere here, right? And your y is 2. Y is 2 somewhere here, I guess. X is 1, y is 2, and your z is 3. I think 3 is somewhere here or something. But again, I think the point is, you see how difficult it is when you get to the level of matrices, how difficult it is to find the point. It's not something that we can't find. Maybe if I do it this way, x is 1, y is 2, z is 3 somewhere. But again, if you're going to, when you start getting to more larger dimensions, right, what you begin to see is sometimes as against lines, you see planes, and trying to make sense out of it with your eyes may not really be as easy as you'd expect. All right. But I don't know if you guys have questions. I expect you also have questions. Questions? Maybe should I put money for questions? Oh, you guys can't hear me?
Please, my question is to determine the dimension of the metric, is it until we plot the metric values on a graph?
No. It's a 3 by 3, 3 rows, 3 columns. Right. I don't know if you get my point.
Not really.
So we have 3 rows. How many, like, this is row 1, row 2, row 3, right? That's 3. And columns 1, 2, 3,
Can you guys hear me?
right?
Hello? Hi.
Hi.
Hello?
Yeah, TJ,
Sorry.
can you?
Yeah, I can. So I think I just quickly want to jump in to answer a question. She was asking to determine the dimension. That would be the second one, like it's like n by d dimension. So the column is the number of dimension. I think that was what she was confused about.
Oh,
Yeah, like is it like because you had 3 by 3,
yeah.
if it's like 3 by 5, 3 by 8, it's the second one, like the D
Yeah.
dimension, N by D.
The column is, okay. Yeah, the column is the dimension. So usually you have it like as an arrow raised to power the dimension 3. So when you have arrow raised to power 3, the dimension is 3. Is that what you were asking?
Um, it's something like that. But when you did ask a question about the dimension, and you said is because it's in a 2 dimension because it's plane, Abby? Is that how you put it? Um, it was a 3 by 3, and you said it's on a 2 dimension because it's a plane. It's on a straight plane, Abby?
No. On when you view it on a 3D space, right, it appears as a plane,
Okay.
right? It appears as a plane, right? It could have different shapes, but pretty much it will appear as a plane.
All right.
Yeah. Are there more questions?
Yeah, Aniche, so I was kind of like curious, why, when you removed the third row, yeah,
Yep.
it didn't display as a tree on the 3D plane as a 3D plane. Why? Despite the fact that it's still a 2-dimensional matrix, even when you remove the third row.
Sorry, come again.
So if you remove the third row, that's 7, 8, 9. It's still a 2D matrix, not too different from what it is right now. You get. But when you try to,
Yeah. So the third dimension is what introduces that plane look that you see.
but it's still a 2D.
It's a 3 by 3, right? Here, you could still look at it as arrows, really and truly. Right. Let's see if we can represent it with this guy as vectors. You could still look at it as vectors. Give me one sec. Let me see if this plot is going to do that. Right. So you could still look at it as vectors, right? But if you're going to view it as a metric, it's going to look like planes. It's going to come out as a plane, really. Because imagine you have let's think of it as points, right? On the space, right? If you think of it as points on the space, and you decide to join each and every of those points on that space, what you would end up having is literally a plane. I don't know if you get my point. So similarly, right, don't quote me anywhere. If we decide to plot this guy here, and let me see if I can run this one. Is it this one? No. So here, sorry, give me one sec. Here, maybe this is a better explanation. Here, you're plotting individual, I mean, frame is not even individual stuffs, right? I think it's the same thing. Let's change this guy to matrix, right? I'm sure it's not going to work, or most likely not going to work. Check what this is. I'll put this here. Of course, it didn't work because it's not vector. Okay. Yeah, so the shape is not a shape of a matrix, right? But really and truly, right? If we convert this guy to a matrix, right? What you're going to have is still going to be something similar to this. So in one case, you're representing it as points with magnitudes and the rest of it, right? In the other in the other plot, you're looking at it as more of a plane because it's a matrix. And really and truly, you should be kind of looking at matrices as planes, right? Again, depending on what you want to get out of what you are doing, you might want to look at it as a plane or an arrow, right? So sometime in your course, right, you deal with something called gradient descent, right? And usually gradient descent looks more like on 2D looks like a bell-shaped kind of I mean the not gradient descent entirely, right? But when you're describing it or when you're teaching it, it looks more like a bell-shaped inverted bell, right? Where you're trying to move from some sort of certain point and you're reducing your loss and you want to get to the lowest point, right, of your loss. However, it makes more sense when you're dealing with gradient descent to look at it from a 3D point of view. And you look at it from a 3D point of view, what you'll have instead is, I've messed up all these things here. One sec. What you'd have instead is you have something like this, but you see this is a plane. But what you would have is a plane that is kind of depressed. When I mean depressed, it's a bell when you look at it on 2D, but it looks like a round bottom cup, right? That is going deep down. Let me see if I can find something. And in such cases, right, you don't want to view, sorry, I don't know if you see what I'm sharing now. Are you able to see?
Yeah.
Yeah. So in that case, right, the question now is, would you want to view your plot as an arrow, or would you want to view it as this, right? So for example, here, let's use, right, you see, if you're looking at it as a line here, you're basically saying, oh, I'm here and I'm moving down, 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 right? And again, this is not arrows, these are lines, these are curves, right? And I'm moving down, 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 and then I want to get to this point. Well, the interesting thing is that what you might be looking at as just a line may not actually be a line. It might be something that looks like a mountain like this, and you're somewhere here, right? And all you want to do is go down, 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 then go left, then go right, then go right, then go left until you get to the lowest point here, all right? So most times visualizing things like that, right, you want to view it as a plane as against viewing it as some sort of lines, right? But I don't know if that makes sense.
Yeah, it does.
Okay. So let's move on. Are there still questions? If I said $2 now, everybody will talk. Okay. So addition and subtraction. Who can tell me the shape of this matrix? Anybody?
That is 2 by 3 matrix.
2 by 3.
Yeah, this is
Why is it 2 by 3? It does not
Yes,
look like
2 rows and 3 columns.
why is it not 3 rows and 2 columns?
Because it's row major order.
1 by 3 and 1 by 3.
Yeah, you're right. So how about this one here?
That's a 3 by 2 dimension.
Yeah,
3 by 2.
Okay. So I think I put some to-dos here. Let's do one of them. And it's you guys that'll be doing it, right? So let's do do you guys have your notebooks open with you? You guys have your notebooks open with you?
Yeah, I do.
So does anyone want to try out? So for the person who has his notebook open, you want to try out adding these two matrices and tell us what you get.
Okay.
But if anybody has the answer off his head, he can also tell me too.
Okay, so it could not be broadcast together because their shapes are different.
Nice. So what can you do? If you're going to trickishly, you use the word trickishly, make it work, what would be the expectation?
I'll need to fill maybe one of the this with zeros. The one with the shape of 2 by 3. I could add the one with the shape of 3 by 2. I could add zeros on the this thing.
Yeah, so basically the point, I think the point which you raised, which is very correct, is the fact that if you're going to do additions, right, it should be of the same dimension, right? How about subtraction?
The matrices have to be on the same
shape.
dimension to work.
So I mean, you guys have done the assignment. How about this one?
Okay, so adding this, they have the same shape.
Yeah.
To give us the first matrix will be 8, 10, 12,
Yes.
and then 13, 15, 17.
Nice. Even though I didn't want you to give everyone the answer. No.
Oh, okay. Sorry.
No, you're right. So, because you had your notebook open, right, and you're also trying things out. I don't know how much is left, but the last one belongs to you. Or you've taken something before.
I took only $3 now. It doesn't hurt to get more.
One more. Okay. So dot product, right? So think of it like if you're doing multiplication. So there's also the dot product operation in matrices, right? You learn. I'll tell you that for free that you're going to use this a whole lot as you do ML, right? When you're trying to, for example, carry out some complex computations, say you're doing, take for instance, you want to do some sort of quick, I usually call it hypothesis, right? To say you have x, y equals mx plus c. I'm sure everybody knows that, right? And you want to do that for data in very large dimension, say 10,000 rows, you understand, of data over, and then maybe 10 columns, that kind of thing. And you want to quickly do your y equals mx plus c for each row, or even if it is just one, even if it's just x and y, you want to do your y equals mx plus c quickly, right? For all row data, your dot product becomes really, really powerful there, right? So understanding how dot products work is super important, right? When it gets to higher dimension computations, right? Even in deep learning, it's also very, very, very important. So I mean, there are some rules in doing matrix multiplication, and really it's an x by n matrix. You can only do the dot product between that and an n by, say, b matrix, right? and this, in this case, these two matrices. So these two matrices satisfy that case, right? So here you're having a 3 by 2 matrix, right? And it would work, the dot product would work with this B matrix because it is a 2 by 3 matrix, right? So the dot product of A and B works. So my question to you all now is, a dot product of B and A, would it work?
No.
Why wouldn't it work?
We don't have the same dimension, both of them.
No. I mean, it's not like you don't have the same dimension, right? It doesn't satisfy the rule, right? So we can try it out.
I think I'm missing something. I kind of like tried it out on my and it worked.
Let's try them. Right. So this is A and B. Let's try B and A. Okay, interesting. So
Hello?
maybe we need to spell it out. It will work actually. So I take that back, right? Maybe my brain isn't working. So
Please, sir, can I ask a question?
Yeah, please.
From my side, I don't know. Mathematically, should it work normally?
Yes,
Like,
it will.
no, if we have to compute it by hand, would it work? Like, that's my question.
No, there's a way you calculate it. We'll get there, right? But that's going to be you guys' assignment. So just to clarify, I didn't get, what's your name? Sorry, please.
Me?
Yes,
You guys? Rihanna.
Rihanna. Okay. So this is the rule, right? And my apologies, I am the one who made a mistake before. So your vector A is what? It's you said it's 3 by 2, right?
3 by 2.
Good. Your vector B.
Yes.
2 by 3.
2 by 3.
Right?
And then this is the rule. So I'm asking the same question again, right? If we do A times B, will it work?
It will work. We'll have a 3 by 3.
Yeah.
True. So if we do a B times A, would it work? No, if we do an A times B, it's what? A 3 by 3, yeah? If we do a B by times A, will it work?
B is a 2 by 3.
If we do A times B, we'll get a 2 by 2.
Sorry.
Yeah, both work.
You guys.
It's
Sorry, this is 3 by
3
2.
by 2.
Okay.
2 by 3.
So
columns of
A times
by
B.
columns of B.
Yeah.
By rows
A
of B. That'll be 2 by 2.
Yeah. So A dot product B is what? It's the 3 by 3, right?
Yes.
Side by side.
I'm seeing a 2 by 2. I don't know
A
if
and B.
Yes, A and B.
No,
A
that
2
shouldn't
by
be.
2.
No, it should be a 3 by 3.
Should be a 3 by 3.
It should be a 3 by 3. Because I mean, one way to intuitively think about it is that when you have your A by N and you're doing a dot product with your N by B, you can almost imagine this
Okay.
kind of thing.
Okay, yeah.
Dimension by this dimension, right? So it's going to be a 3 by 3. Were you able to correct it from your end?
Yes, I was able to.
And when you do a B by A, the last dimension becomes 3, and then you
3
have
by 3.
no 2 by 2. When you do B by A, right?
B by
The
A.
result is 3 by 3, right?
Oh,
Sorry?
I see.
So B by A is going to be 2 by 2.
Yeah,
Yes,
you do
2
like
by
a
2.
backward slash.
Yeah. Right. So all good. So what if a trick question now? What if this guy was a 6 or a 5? Yeah, let's do it. A 4. Right. Are you sure?
Yes.
Are you sure?
The rules of the number of it will work.
It
Well,
will
we have
work.
a 3 by 4.
Yes, we have
It
a 3
will
by
work.
4.
The
If we
condition
have
is
a 3,
still
the
there.
number of columns of A matches the number of columns,
Number
the number of rows
exactly.
in
Rows
B.
in B.
So it will
Exactly.
work.
Yes,
It will be a
it will
3
work.
by 4.
So thank God you guys corrected yourself. Let's put it to test.
A 3 by 4.
So it works, right?
Yeah.
So you guys get the concept. So just put this at the back of your mind, right? Anywhere you go. It's very useful. So yes, dot product. So how about this one? Right? Would this work?
How many columns here? 3 columns. How many rows? How many columns? 1, 2
So let's
columns.
write
you
it out
do
so we don't make mistake. Even me myself, I'm not immune to mistakes. So we have A as what?
3 by 2.
3 by
if you do P
2.
times A, it should
And
work.
your B is
This is
what?
3 by 3.
3 by 3.
It won't work. It
Won't
won't
work.
work.
So
It
what
will
if
work B times A,
It will work if you do B times A.
but it won't work for A times B.
A times B won't work, but B times A would.
Yes.
nice? And then another thing is you could transpose. There's something called transpose. I think this is supposed to be A transpose, not B transpose, though. Can you all hear me? So when you do a transpose, right, literally what a transpose is doing in the real sense is like it's twisting, not twisting, but it's what's the word?
Like writing the
Inserting the
columns as
position.
zeros.
A 3 by 2 to a 2 by 3. I don't know if you get my point. Let me see if I remember how the
I think transpose does
It's
it
more like your row
switches the
becomes
It
your
changes
column
the
for
column.
the
Row
rows,
row.
is
columns,
to
and columns.
columns.
Exactly.
You guys are superb. I think I like this class. Maybe this should be the best class I get. All right. So yeah, it changes your rows to columns, your columns to rows. I'll advise you guys to try it out, right? And see how that works. But when you do that, if you do your dot product, it's going to work. Now someone asked a question. So this is an assignment, and I'm just going to give you a hint. And I think there are a whole lot of assignments. This class is supposed to be for how many hours? 2 hours? 2 hours, right?
Yes.
Permit me to take just 5 minutes. Right? I think 5 minutes will be fine, please. So if you're going to do your dot product, again, I would advise you guys to go through the exercise yourself, right? There's something called determinants, right? Which is a very, very useful gadget. And then inverse of matrices, right? So there are things that you would want to know how they work, right? And why they're important. And then I would say pick a very small matrix, do a 2 by 2, multiplying a 2 by 2 matrix. Calculate it by hand, it's not hard. Then move to a 3 by 3, multiplying a 3 by 3. Again, like I said, it's not hard. Now, when you guys have done it, you literally need to do an inverse, do a determinant, calculate your determinants, then do the inverse of the matrix, and then you do a transpose. Like it's a couple of things all together that we've learned, right? I think the only thing that you've not learned is how determinants are calculated and how inverse are calculated. Now, when you're done calculating that matrix, the dot product of that matrix, right? Use your NumPy to calculate the determinants separately. Like every of those procedures that you took on paper, right? You do the same thing with code. Now, without using the NP dots, anything, just more or less like go through that process with code and see whether it gives you the same answer as what you would have when you do an NP dot, right? So the reality is that under the hood, that's probably what this guy is doing, right? But understanding how these things work, right, goes a long way in your understanding of this entire concept in and of itself. And the interesting thing is that you'll be able to know or debug when there is possibly an issue with what maybe some sort of research work or experiment that you're doing, right? Now, already I think I put the line of code that you can use, but try to solve it with hand first. It might be a bit cumbersome, but it's very, very valuable. Now you can actually do things like simultaneous equations, right, with matrices. The simultaneous equations they used to use and frustrate us in class then, right? You can literally use matrices to solve them using your dot products you get. So I told you dot products can be very, very valuable. Now imagine that this is, I know I mentioned y equals mx plus c. Now imagine that this is 1y and this is, no, this is x, y, and c, right? Just imagine for a second that this is x, y, and c, right? It already means this is some sort of matrix that is equating to some sort of matrix here, right, or vector here. And you can literally use it to solve simultaneous equations. The interesting thing is that if you're going to go the programmatical way of solving simultaneous equations with for loops, an interesting thing you'll find out is that where your for loops might take, I don't want to exaggerate, right? But if your for loop is taking you 2 minutes, no, 1 minute to run and give you an answer for something that is very large, it's very possible, now don't quote me, that your matrix will solve that same thing in maybe 1 second, right? Because it is super, super efficient, right? Then there is also the concept of sparse matrix, dense matrix, right? I'm just trying to wrap up quickly, but I'll leave you all to um, take a look at all these things, right? So sparse matrix, dense matrix are matrices that have like values in the nature of its elements, right? The elements are densely packed, so it's having values greater than 0. But a sparse matrix, most times you have multiple zeros here and there, right? And I think most times when you're dealing with sparse matrices, when you want to kind of have your matrices as more lightweight, right? But even beyond having it as lightweight, right? Computations become a bit less cumbersome, right? And I think there are two. One is row, and then one is column. But do research about that. I think this is the part that I really, really like, where you guys are going to. So for those of you that have, I have quite a number of things here. I think these are going to be assignments. But Yomife, please, can I have 2 more minutes, please? Is everyone fine if I have 2 more minutes? So I want everyone to, at least for those who have their notebooks open, right? So there's an image of why did the image disappear now? Okay, yeah, this is it here. How many of you know this woman here?
This is Ladikwal
Yeah, so where do you find her? Where is she?
on the 50 naira notes in Nigeria 50 naira notes.
Nice. So I need you guys to do something. Play to this image, right? Again, you can also imagine images as they are pixels, and pixels are values, they are numeric values, right? Ranging from the 1 to forgotten the number. Well, it's a range of numbers, right?
64.
0 to 255.
Yeah, 255. Right? Pardon the brain. Right. Well, there are arrays of numbers, really, when you look at it in say NumPy, right? And you can literally view them as matrices, right? Plotted on a plane, all right? It's on a 2D plane, right? So now, when you plot those values, which are different ranges of numbers or pixels on a 2D plane, it gives you a picture. Now, I need you guys to do every of those operations we did, addition, multiplication, just do something, maybe just multiply it by a scalar, multiply it by, I need you guys to play very quickly in 2 minutes, play with this image, If we don't have anyone in 2 minutes, then it would be nice if you put your results on the Discord channel. All right. Now, if you're able to do it in 2 minutes, play with it in 2 minutes and put it in the chat or share your screen, the last $5 goes to you. Deal? Do we have a deal? No one.
Please,
Yeah.
sorry, please, can you clarify the question again?
So I need you to play with this image in any way or form, right? Considering it as a matrix, right? I don't want to shout, nobody should send me this same picture that I put here or this one here, right? I need you to play with it and turn the image to something else, right? Just multiply anything that makes sense or add anything that makes sense or subtract anything that makes sense or do a dot product of anything that makes sense, right? And then put it in the chat. 2 minutes, what's the time now? So by my time, it will be 7:12. 12 minutes past 7. So I'm waiting.
Yeah, I have something.
Wonderful. Okay, share your screen and
Okay.
walk everybody through what you did. I'll stop sharing now.
Okay, can you see my screen?
Why don't I see it? Sorry,
Okay, I'm coming. Just a moment.
need to stop sharing. Okay, I'll stop
What
sharing.
about now?
I don't see it.
That's
You
your
have
team
to
you are
make it.
presenting. You actually showed it initially before.
Oh, okay. Let me switch again. I'm using a multiple screen. Okay. So this is it. So I kind of like added, I know that it exists in red, green, and blue. So I added
I can't see his
the whole
screen. Is it me? Oh, okay, yeah, I can see it now. Sorry. My
Okay.
apologies.
Yeah. So I know that colors primarily RGB, they exist in red, green, and blue. And then a pigment of that kind of like creates all other colors. So I kind of like added an extra spice of red, zero green, and more blue. And this was the result. This here. I could play with it by making this, let's say 12, give it more spice of green, and then just a drop of blue. And then I run this, and then I run this. And yeah, more green.
Nice. Very beautiful. One question. Did you collect money before? Don't lie.
I collected what I mean.
I think this is like the third time. Let me be back today.
We'll divide it by 2. So someone else that has not collected, let's give someone that didn't have a
I mean,
chance.
the last time it was $3, so you can just give me like 10.
3 plus 1, that's 4. I remember your name.
3 plus
3
1,
plus
that's
1
you.
Even
plus
now is 4.
No, now that's going to be another 1. So that's 5.
5. How about now?
So,
Why am I
so
not growing
somebody
exponentially?
so let's go with someone that did not answer or hasn't had the chance to get something. Anybody?
I did change the mean to STD, and it
Yeah,
made
share
the image saturated.
your screen. Let's see it.
Okay.
So talking about it now, I just remember that there was some project I did. Okay, but when you're done with your presentation, maybe I'll share it with you guys. Or maybe if I find it, I should be able to find it.
I don't know.
Please,
Is anybody seeing my screen?
yeah,
Yes.
I see my name. Ah, man, some people already putting my name on the screen. Hey,
Wait, is anyone seeing my screen?
I think you stopped sharing.
Alright, are you seeing now?
Yes, we
Yeah.
can see.
Okay. Oh, it's coming. All right. Since you said 2 minutes, can you hear me?
Yes.
All right.
Feel
Under
free to
gray
drop off.
underscore image, since
Mhm.
it was limited time, equals image underscore array. I changed the mean to standard form to STD.
Mhm. Nice. I didn't even think about that. So yes, I mean, because you did something that made the image change, right? Which makes sense, actually. I mean, from the perspective of computer vision and the rest of it, right? You did the right thing. So that's fine for you. So that's the end of giveaway. Right. So I was going to
Am I
someone,
still audible?
yes, you are.
All right. Sorry, my laptop went off.
No
Luckily, there's
problem.
light. All right. I was saying to me that there was much time, so I just changed the mean to STD. That's all I did, and the image became saturated, more gray. Yeah.
Right. So I was going to share something. I mean, how many more minutes do I have? I'm sorry, I like talking too much. My apologies. But feel free to drop off. But I wanted to share something which I'll probably put on the Discord channel. Some other extra that you know what? I'm just going to put it on the Discord channel. I don't want to bore you guys with it. But there are a couple of other activities that you can try out, right? Things like, and this again, it still goes back to concept of linear algebra, right? Where you can literally do things like blurring edges, right? These are very complex tasks, right? Where you blur edges. Maybe I can pull it up. Just give me 1 second. But feel free to drop off. I know I've gone out of time, right? Feel free to drop off. Trying to pull up the document.
Okay. Hi everyone. While Mr. Kenneth is still trying to pull up the what he has for us. So sorry, our time is fast spent. This week we'll be diving into okay, probably when it's done, this comment will be diving into NLP. And also I want to like show the sequel question 1 and question 2. So after review and after a lot of after review, we said that okay, since the error was from our side and what the instructor did, probably there was no time to like do it proper. What was inside that notebook was a bit. So probably Mr. Kenya, have you gotten it or
No, continue.
I should
Continue.
proceed? Okay. So while we're that, let me share my screen. Let me open the notebook and share my screen. Okay. Am I audible?
Yes.
Yes, you
Yes,
are.
you are.
Okay. Okay. So there was a lot of engagement with it because money was involved. Everybody likes money. Yeah. So can you all see
You
my
do this
screen?
more often.
Yes, yes, sir. We with it's a report ongoing. So yeah, we'll talk more about it later. So can you all see my screen?
Yes, please.
Yeah, exactly. So the issue was majorly because while in the solution that was inside the notebook, you see this in this query. Can you see it very well, or I should like zoom
Yeah,
And
you
we
can
can
see.
see.
Can see it.
in?
Can see
Okay.
it.
So this the issue was with this product key. So if you look at this, if you look at product key, if you are looking at product key now, is the product key is just telling you what product was bought. Where is the that one's okay. Product, look at this is product key. Product key is just telling you what item was bought. It doesn't matter when, where. Do you get? And remember, we're just trying to we need the product that was sold between a specific time frame. Do you get that? So that was what caused the issue because we were using products which this product skill will just like give us everything regardless of is to just give us everything. So even though we are specifying the data, it will still, since we are selecting the product skill, it will still give us sorry, it will still give us product key that are outside these dates. So that was what caused the issue, and we had a lot of that was what caused the issue. So there are different approaches to the question one and question two. So as you can see, so you can try this method, or you can try this as well. Yeah.
But
Okay.
Yamife, from there you can see
Yes.
that in question one, the answer is not in the
Yeah, exactly. So the answer is not in question. So question one and question two, like they are not they are not. So we apologize for that. And so the thing is, regardless of what you choose for your as your answer, we will like oh it will be a bonus. Question one and question two will be a bonus, but you guys need to do so 3, 4, and 5. You guys also need to do. But regardless, I hope it was a nice journey exploring with SQL.
Sorry for those that did not submit because we're waiting for
I've not
this
submitted yet too.
verification.
Yeah. So
We should go
you
ahead
have a
and submit.
grace till so tomorrow. So you have the grace period of tomorrow, end of EOD tomorrow. You guys must have like submitted this particular assessment. But so regardless of what you guys, even those that have submitted, I would have probably changed the option. But since some people have submitted, it won't be fair on them to like just change the options that they get. So, but regardless, so the answer is actually 15. So this is clerical, 15. This is manual, which is 5. So apologies for the mix-up. So it was because
I
we were
got
using
15
products.
and 5.
Yeah. Kudos to everybody that got 15 and 5. Some people also reached out to me that it was 15 and 5. So I have to like look into the SQL query that what was wrong. And thanks to Mr. Aditola, she's also on the call. Yeah, we had to do a lot of debugging together, and then we actually found out what was actually wrong in the original SQL query. So yeah, that was just what I wanted to point out. So yeah, Mr. Kenichi, are you ready? Or I should proceed?
Yeah. Sorry. I'm really, really sorry for the delay, right? I'll just go over it very quick. I just wanted you guys to see some It's just so think of it as motivation, right? You can try this at your leisure. Don't necessarily need to, but to be, I think I'll be super excited if you guys try out these things, right? So it
Should I stop
may,
sharing? Do you want to share?
You can see
I'll
your
check.
screen.
I'll check. So some of these things might require a bit more um, mathematical stuff to write, which you can research about. But some of the beautiful things that you can do when you play around with matrices, right, and a bit more mathematics is you can by yourself, right? You know, some of those effects that you see in images, right? You can begin to play around them. So, for example, this is an original image I took, right? And you can literally turn it to a grayscale image, right? The normal grayscale you see on your phones and the rest of it, right? And there are formulas that you can use to get that done, right? You can use this formula. Use your red, green, blue squared times an alpha. As you change the alpha, it kind of changes the way how the intensity of the grayscale, right? You probably have seen this also, right? You can try to see how you can replicate a sepia tune, all right, as you would see in your phone. I can look for the equations or the formulas or the methods I used to do this thing, or even the code. But I think this was done in C++. You can do a blur, right? So a blur is literally it's basically you applying a 5 by 5 filter on an image, an array of numbers that is represents an image, right? And when you apply it over all those images, right, it's going to give you a blur effect, right? So that blur that you see in images is literally basically some algebraic operations, right, happening over as you slide through each 5 by 5 window in an image array, right? You could do a Sobel, right? A Sobel helps you find lines either in the x-axis when you apply an x Sobel or a Sobel x, right? Or in the y-axis, right? And a Sobel is basically like is a 3 by 3 matrix that you're applying over all your images, right? So this was the original image. And if I literally wanted to find all the vertical lines, right, in my image, I would apply an X Sobel, right? And you see all the vertical lines. When I apply a Y Sobel, right, I'll see the horizontal lines, right? So you're literally saying that when you're dealing with images, right, it really, really goes beyond just, oh, let me just multiply 2. Oh, let me just multiply 3. They are very, very powerful things that you can do, right? This is blow and quantized that you can do. And even to the extent of even, I mean, at a very, very basic level, right? Some sort of face recognition. Well, again, this one is a bit more advanced. You can do something like an embossed effect. So I look like a fresh guy here too. Embossed effect. You probably have seen this. This is cartoon effect, right? If you want to look at me as a cartoon, there are probably better ways of doing this now, right? But this is basically some nice things that you can play around with, right? Just to give you guys ideas of things that you can play with. I think I'll be super excited if I see that you guys are trying out some of these things and putting it on the Discord channel. Trust me, I'm going to be super excited. We never can tell what will happen. I'm not promising anything, but try it out. Put it on the Discord channel. Put it on Twitter, tag AI Saturdays. Put it on LinkedIn, tag AI Saturdays. And you never can tell. Maybe somebody might be interested and be like, "Hey, we want to hire you for this kind of thing you've done." We get let people know that you're doing stuff, right? That I'm not just being my. Yep, that's it. Thanks, everyone. I really appreciate it. Thank you.
Thank you.
Thank you.
Thank you. Kelechi. Please, a round of virtual applause for Mr. Kelechi. Thanks so much for the lightning session, for the dollar bills that rained, for everything. Thanks so much. Really appreciate you. Thanks for gracing us with your presence. So yeah. So I hope everybody has been able to like learn a thing or two from the class. So if you haven't gone through the material, so if you haven't gone through the video and the notebook, please do try as much as possible to to interact with the notebook. Also, the material is shared will be gotten across via email, and we'll also send it on the Discord channel. So thanks so much, everyone. So
Hello.
yes.
Sorry, I just wanted to ask a question. It's
Yes.
concerning that when you were showing the last assessment. So I think they were like, because they sent one assessment link via the email, and there's also another way to access that link is also on the GitHub page. So I think the one that was firstly sent, that first question was just January 2015. It did not like narrow the date to like January 11th and January 18th or something like that I just saw on the screen. I don't know if you understand what I'm saying.
Yeah. Did you submit it before it was edited?
Yeah, I've submitted already, and what I used was January 2015. But later, when I tried to access the link from the GitHub
Please,
page, I saw that it was January
please,
18th to January 23rd or something like that. I don't know if you understand what I'm
sorry.
saying. Yeah,
Yeah.
so I think that's when
Sorry.
you.
Okay, the confusion came in from your side. No problem. So
I have
apologies
a
about
question,
that
please.
as well.
Sorry, I'm having issues with my GitHub. Like I can't push from Google Colab to GitHub, and I've watched like YouTube videos. I've tried. There's like this user interface where you just click a button and you can just on Google Colab, but it's not working for me, and I don't know like how I can go around the issue.
You can do it directly.
Yeah, you can actually do it directly
From
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 Google
from that
Colab.
your from
That's
that
what
your
I did.
page.
Yes,
You
I
see
can do
From
it
the search
directly,
bar.
and I've tried it, and it's not working.
Wow. Maybe I'll
Wow.
record a video and share. Because that's what I
Okay.
did.
Okay.
I never stress myself to do it locally. From
It's
Code
like
Lab, you select the
yeah, you
GitHub and
just
then
click the I
you select the project. You just make
you
sure you're
yeah, I created a project on GitHub.
Yeah.
Then I have a project already. Like I already have my code on Google Colab. Then I just on Google Colab, there's this like I clicked something. Then something about go to. If you go to Google Colab now, I can show you what I did, but it's not working for me. Like
Okay.
everything is connected successfully,
can
but
you
it's
play
not
there for
working.
let's
Yeah.
try it.
You know what? Sorry, our time is fast spent. Sorry, we are supposed to end this stuff by 12, and this already 12. Let us continue this thing on Discord, please. On the
Mine
Discord
is not a,
channel. Let's just like round up.
Mine is not a
Sorry?
question. Mine is not a question though, but I was the last person that
Yeah,
shared
yeah,
my
yeah.
my screen. I don't know if I got the prize or not.
I think you
You
did.
did.
I think you did. You did. Don't be scared. You know what? For everybody that has gotten a prize or two, please reach out to me on the Discord channel. Tell me the question you answered and the amount the amount you won.
Ah,
I also mistakenly
I forgot the
you,
question.
you did not mistakenly
no,
win
no, no,
anything.
okay,
You won
okay.
it.
Yeah, no, the thing is, at the start of the session, when you guys were not responding, so I came up and answered one of the questions, and fortunately, it resulted in me winning some dollar bills. So
That
I think
question
this,
Yeah, I didn't even
that you
know
got
how
is
much I
visible.
got
I
because of
answered
my
it
laptop went
again
off.
before you talk.
So
To be
regardless,
factor, I think.
just reach out to me. Reach out to me. I know the number of people that won the dollar bill. Once it exceeds that, then I don't know. Maybe just reach out to me. Let me say
But you don't need
don't
the
let me say
money
everybody.
now. You don't need the
Sorry,
money, sir. You can give
I
somebody
don't.
else the money.
Who said that? Who said I
Collect
don't
your
need the
money.
money?
Oh.
All right. Okay, so let's just round up. So for those that person having is there precious you that having issues with? No, just let us know on the Discord channel. Anybody can always help out. Doesn't have to be me. Doesn't have to be any of the. Just please reach out on the Discord channel and let's so please let us also reach out on. Let's talk on the Discord channel. We are not like reacting that much. Also, I don't know if we should have if we call for a Discord lounge meeting now, people don't show up. So that's why I don't even really like do it last. We didn't. I think that's why I didn't even like call for it this week. The previous week, only one person showed up, and I waited for over an hour. So I don't know. And some people were saying that we should have more engaging session. But if I call for an engagement session, you guys don't say okay, we should have it at this time. And even when I say okay, let us have it at this time, you guys don't show up. So I don't know what I can do. So regardless, however you guys want us to do it, let us talk on the Discord channel. We can always talk there. So Mr. Kenichi has done justice to giving us a high level overview of you can say that's like a sneak peek into computer vision, like image processing and stuff like that. That is the basics of image processing. You see how image can be processed, how you can transform images between different forms. So for people that might eventually get interested in computer vision, please, that you can see a way, and you can see that this lecture also builds on top of what we did in NumPy in the week one. So everything builds on top of each other. This linear algebra now will also build on top of it by next week, even in the coming weeks, because we'll be going more into like building okay, in the coming weeks, because we'll be going into machine learning algorithms and even processes. So please let be intentional about it. Please go the extra mile. Try these things out, not for anybody, but for yourself. Exactly. So this week we did a brief introduction to a sneak peek, not an introduction, a sneak peek into computer vision. This next week we'll be doing like text processing and a very basic introduction into NLP. This is natural language processing, not transformers, not all this, not ChatGPT, not deep learning. This is just normal statistical stuff that we do in NLP. So we'll be having an assessment. Exactly. So whatever was done in this lab, we need you to like practice it. Am I audible now?
Yes, you
Am I
are.
audible? Okay. Sorry, my network went off for a bit. So as I was explaining, it will build on the what's it called on the web scraping assessment. So whatever was done during the lab, we want you to like practice it with your using the data sets you scraped, the data you scraped. So that's basically what this assessment is. It's a very open-ended. Go above, go beyond, try the multiple things, try different approach. Do the there's sentence similarity, there's embedding, there's a lot of stuff that was done there. So please just try them out, and let us know your findings. So that is that for this week. For this week on for this week community session, I think that will be all. Don't forget to save the calendar. Don't forget to subscribe to our YouTube channel. Don't forget to follow our G12 channel as well. So thank you very much everyone for staying till now. Really appreciate you. Thanks to Mr. Kenichi once again. Thanks to Teju. I'm not sure she is available. And thanks to Mr. Adetola too. Is she
I'm
still on the
here.
call? Oh,
I'm here.
okay. Okay. Do you want to say a word before we round up?
Oh, no. Just wanted to thank Kenichi for waking up so early and everyone for participating. Now, Kenny has set the standard high. I'm like, I need to find a job so I can start paying people. Just joking. Really engaging, and it was nice to see all of the engagement in the class.
All right. Mr. Adetola, do you want to say a word before we round up?
No, nothing.
Okay. All right. Okay. Thanks so much, everyone, and have a nice weekend. Catch you on Discord channel. Bye. You can drop off the call now.